So thanks for joining the Vicc Virtual Molecular Tumor Board call today. We have an exciting presentation from Bob Dolin and Yuri Quintana. They've been involved with some architecture of an application that helps communicate between kind of databases, lab folks, and electronic health records. So Bob Dolin is a senior informaticist, like a bioinformaticist. Sorry, I'm still drinking my coffee this morning at Ilamu Informatics in Oregon. And Yuri Quintana is at Harvard, and they have been working together on this project and looking to submit a grant and looking for feedback specifically from our group to help to kind of further their progress on this application. So thank you so much for being here, and hope that we can collaborate on this.
Right. Yuri, do you want to kick it off with your slides, or how would you like to do it?
So maybe we'll start with just a bit of verbal background as to what we're trying to do here. So I lead a research group at Beth Israel Deaconess Medical Center, and we have developed a molecular tumor board application. Interestingly enough, it launched just before COVID, and so then all of a sudden COVID hit, and we all had to sort of go and become online people. So we've been running it for a few years. We are a cancer center at Beth Israel Deaconess Medical Center that we're part of a bigger center. We have a network called Beth Israel Lahey. It is 13 hospitals, of which we have 2 or 3 other cancer clinics, Lahey being the second largest, and then we have 2 other smaller clinics. We have 17 other affiliate centers. So we're probably the second largest cancer center in the region, soon to become the largest one, because we're building a brand new cancer center with Dana-Farber. It'll open in about 4 to 5 years from now. We're going to merge our patients and have a brand new building. We're also going to create a brand new infrastructure, create a new Epic instance. And part of the challenge is how do you then integrate all the different research databases. And so in the tumor board world, we have sort of this siloed problem that there are different groups who have developed tumor boards, and that data mainly sits at their own center. And one of the things that we haven't done very well is sort of capture what we've learned from those tumor boards, going back historically to learn from them. And we also haven't done a very good job of connecting what we've learned across centers. So eventually, some of those interesting cases become a published study that appears in a journal, but that can take 2 or 3 years. And eventually, some of those novel variants make it into some of your databases, and people. But that whole process is years in the making. And for people that are looking for solutions now for clinical care, that is a long, long time to do that. And to accelerate research, we need a better way to learn from these different cancer centers in more real time. So I've been working with Bob in the HL7 community to see how do we improve the data models of how we store data in these virtual tumor boards, and what kind of infrastructure could we build to sort of share that data across centers so we can learn in more real time. And the specific connection with your group is, for those novel variants that we're discovering, how do we submit some of that data faster to you, such that as it starts to appear in the literature, you at least have had a heads up at least a year or 2 beforehand, and start making that available. Even if we just notify people that there are these novel variants, maybe there are published studies, it would sort of accelerate people who want to study them. So we're particularly interested in understanding your ecosystem, how you ingest data, how you prioritize things, and how do we make what we're finding across these virtual tumor boards available in more real time. So I've got a few slides that, oh, I'm not able to share screen. If somebody can allow me to share screen, I can go through a few quick slides.
I will fix that for you.
And then I will take you. Okay. So let me take you through it. And I really want to spend most of our time just chatting and learning about your group. So let me just give you a quick overview of what we've been doing here at Beth Israel, and then Bob can talk about some of the further work we've done with HL7. So really, this sort of summarizes that, you know, despite the fact that we have a lot of precision oncology, most of that knowledge is sort of landlocked in some of the higher academic medical centers. And we also have not been very good at enrolling patients of different socioeconomic status and genetic diversity into our trials. So you probably know a lot of trials don't get the recruitment levels. And so we need to be able to integrate data across a greater diversity of people by genetic diversity, socioeconomic diversity. And, you know, report after report comes out that there are healthcare disparities in cancer that are startling, and they've been here for a long, long time. So, for example, Afro-American men and women have sometimes lower incidence of a cancer, yet a higher death rate. So why is it? Is it all because of access to services, or is maybe some of that because we haven't developed tailored precision medicine that meets the genetic profiles of other people? It's also sort of similar for Hispanics. And so there are report after report that show the disparity based on where you live. But even if you do a deep dive in larger metro centers, these disparities persist. And so we also haven't taken into account some other social determinants and environmental data. And so how do we make data more multimodal? And how people actually get screened and referred to the trials isn't being done very well. So many people who should be getting screening and should be referred to the right places aren't getting referred to. As I mentioned earlier, clinical trials has notoriously not represented other racial and ethnic groups particularly well. So, you know, there's been these lofty goals by the National Academy of Medicine, a leading think tank in the United States, that we should learn from each other, right? The learning healthcare system. Yet that problem really hasn't been particularly well solved. So prior to coming to Harvard, I worked at St. Jude Children's Research Hospital, where we built a database for pediatric oncology, where you could store clinical trials and outcomes of those trials, and people could de-identify that data and share and learn from each other. And over a decade, we enrolled over 120 clinics, and we had over 1,000 clinical trials, and all kinds of collaborations were developed. And so the speed at which trial protocols were updated dramatically increased, and survival rates increased dramatically around the world. So it was a wonderful opportunity, but part of that it was because we improved how we shared data across the centers. And so as treatments get more complex, and cancers, you know, continue to mutate in all kinds of different ways, people are going to have to find better ways to match the patients to the right trials. And so the speed at which we make these variants known and the tools to match patients to those treatments will have to become better accessible to more people, such that we don't have just these solutions at high-end academic medical centers. So I think there's an opportunity now for us to standardize how we collect that data. We've built a virtual tumor board platform called Alicanto. As I mentioned, we launched it right before the pandemic. We had initial 30 people using the platform in January, and then 2020, and then by March we had 600, and now we have well over 1,000 people. And we have them organized by different disease groups, and they then meet weekly. They review those cases and make decisions, and they summarize those decisions, which is great for us, but no one's actually learning from what we're doing. Some of those eventually get published, but not enough. And so how do we extract the most interesting novel variants that we're seeing and contribute them to other external databases with relevant information. So, what would success look like if we could get 10, 20, or 30 or more virtual tumor boards that collect data more consistently and are all contributing their knowledge to other external databases so people can move on them at a faster rates. And by doing that, then people could connect with other centers to see who is treating patients with some of those novel variants, and then could accelerate how we then document the evolution of those variants into different databases. And along the way, we could augment that data with things that are normally not reported in publications, such as environmental factors, social determinants of health, and other information, which may have an influence to how some of these DNA deteriorate over time, environmental pollution, water pollution, and other things, which we haven't really been able to do it. So the idea is we have some standard architectures. Everyone can still run their own software for their virtual tumor boards, but we standardize how that data is stored locally, extracted, and how we submit that to national databases. And so that's what we'd like to do. And so we have a few other cancer centers that want to work with us. And through the HL7, we've been able to meet weekly. And thanks to Bob's leadership, that group has grown over time. And we have actually started to develop the specific details of the database infrastructure. And we're proposing those standards to HL7. But to make this actually work, we're going to need to be able to have partners like you to figure out how do we work with you to advance that. So let me pass it over to Bob, who will give more details on the HL7 side, and then we'd love to get your feedback and see how we could work better together. Over to you, Bob.
Yeah, thanks, Yuri. Every time I hear you describe the vision, I get very inspired, I must say. So thanks again for that. I think it paints a really nice picture of where we want to go. My perspective, the remarks I want to make are, I guess I would say, less visionary and more down in the weeds. How are we actually going to do this? Because, if we provide crappy software, oncologists aren't going to embrace the vision. They're going to be resistant to the vision. So how do we develop open source tools and open source pipelines and open source, capabilities that can be embraced by not only academic oncologists, but possibly community oncologists and molecular pathologists? How can we build the tools that, clinicians will embrace so that we can drive towards the vision that Yuri just described? And so I'm going to go down a level into the weeds to kind of describe a grant proposal that Yuri and I and others have been putting together, and then hopefully talk a little bit about how we might collaborate with the Molecular Tumor Board, because in the end, I got to say, I'm really excited to be here, because none of the stuff that we're developing is really going to work if it doesn't work for the people on this call, right? If we don't hear from real world oncologists that are treating patients that are having to make treatment decisions, if we don't allow oncologists to throw stones at the software that's being developed, then where does it go, right? So with that, let me share my screen. And so we've been developing a grant, and I guess really where we're trying to go is figure out, are there some opportunities for collaboration? So I want to describe to you a little bit about the grant that we'll be submitting. I'd love to get some feedback from you. As Yuri said, we'd love to hear more about what you all are doing. And then in the end, see if there's some opportunities here for collaboration. We call the project that we're working on a precision oncology learning health system. And so what we're trying to do is we're going to give you an overview of what we're submitting. And this is the idea of this grant, is to develop a suite of open source tools and technologies that enable this learning health system. And we're trying to see if there's some opportunities for collaboration, whether that's simply, real world oncologists that we meet with periodically to throw stones, or if it's a more engaged type of a collaboration based on some of the ideas that Yuri had put in his last slide. So let me just begin by describing the grant, and I want to and can you all see my screen okay?
Yes. Yep.
Okay,
Looks great.
cool. Thank you. So this is a big picture. This is a 3-year project, and this picture kind of shows the big picture of where we're trying to go. Everything that we'll be developing under this project will be made available as open source software and tools. We have a molecular tumor board app. This is an open source Smart on Fire application. Well, I guess let me just point out, these are some early screen mock-ups of the application. So part of it is this, but we also know that, you know, when new evidence emerges and when new evidence is published into the literature, it can take an inordinate amount of time for that evidence to make its way into clinical applications. And so the model that we've been developing, not only within HL7 and the fire community, but also through some collaborative projects with Vicc, as it turns out, with Alex and with Civic. What we've been doing is developing high fidelity annotation pipelines. So in this model here, when the clinician is looking at the molecular tumor board app, we've demonstrated through some prior projects with the Civic team and GA4GH that we can pull in annotations in real time. In our initial experiments, we've been looking at Civic, and I'm just guessing, Beth, that because this is the Vicc group, everybody knows here what Civic is.
Yep. I think that's a safe assumption. Yep.
Okay. And our experiments have been, can we in real time sequence a patient's tumor and pull in annotations? And the experiments that we've been doing are with ClinVar, clinical trials, PharmGKB, and Civic. And the answer is, yeah, you know, we can definitely do it. There's some complex types of knowledge entries in some of these databases that we're still working on. But for the most part, we're demonstrating the ability to automatically pull in annotations. We're also implementing the ability to compute oncogenicity and submit oncogenic variants back to ClinVar using the ClinVar API, or using possibly some other methods in collaboration with, well, it's with Alex Wagner, so I don't know if it's exactly with Vicc or with Civic, but anyhow, so we're working on this pipeline so that if a clinician sees a novel variant that's not available in any of these knowledge bases, they can submit that and then and automatically annotate stuff. And the other thing that we're doing here is there's a couple of domains in genetics where we're starting to see that clinicians are generally not satisfied with the data coming in through a curated lab report because for various reasons they need broader access to the patient's genome. And for patients with advanced cancer, we have cases we've seen where a site may have a clinical trial, and that clinical trial may have inclusion criteria based on a genetic marker that wasn't necessarily reported by the lab in question. And so the clinicians there sometimes are asking to see the patient's raw genetic data, the VCF file. But even when they get the VCF file, sometimes they don't necessarily know how to process it or how to leverage it. And so what we've done within the fire community is set up a method whereby we can have the patient's whole genomic data set in a genomic repository. And this can include the VCF file, BAM files, CRAM files, what have you. And we can surface up relevant slices of that genomic data using FHIR APIs. And so we validated a set of FHIR APIs that allow a clinical application, a Smart on Fire application, to query not only the electronic medical record for clinical resources like problems in meds and allergies, but also query a full genomic repository to have access to any portion of the patient's genome. And so where we're going with the Molecular Tumor Board app, in addition to this loop on the right, is enabling the Molecular Tumor Board app to have broad access to the patient's electronic medical record and to have broad access through these FHIR APIs to the patient's complete genomic data set. And that's what's signified by number 3 here. And then finally, the lines connecting these repositories is meant to represent a federated data model, whereby one of the things that you'll see here is that, you know, if we have FHIR data in the EHR, and if we have a genomic repository that's FHIR enabled through these API wrappers, you begin to set the foundation for a federated database where you can pull in similar FHIR encoded data from any node. And so you begin to open the door for translational research. You begin to open the door for different types of data marts, right? That basically leverage real world evidence so that to further enable translational research. And of course, the other learning health system pipeline that's not shown in this picture is from that translational research comes literature, and from that literature comes annotations that make their way, for instance, into Civic. And so now anything that's gleaned from the literature, and as soon as knowledge is imparted into Civic, that knowledge is immediately available to clinicians using this app. And so here, I think we've vetted this model, and I'm going to dig into some of these pieces in a little bit more detail. But again, just to kind of describe why we're here, you know, we've vetted this now with maybe 20 clinicians. I would say maybe 10 to 12 oncologists. Many of them are academic oncologists. We've vetted this now with molecular pathologists. And what we're, you know, over the course of the grant, which is a 3-year grant, you know, how do we stay on track? How do we ensure that the direction we're going with this precision oncology learning health system model really resonates with frontline clinicians? Because that's really, to me at least, in the end, if we don't get the Molecular Tumor Board app right, then none of the other stuff really matters, because no one's going to be using this at the point of care. And so I see this group as a group of experts that can really weigh in on what does this app, you know, really need to do, and what is my thought process as I'm treating patients. So let me just dig in a little bit more to a couple of these pieces, and then we'll kind of come back and have a little discussion. So this is a Zoom.
Can I interrupt you?
Sure.
Sorry. I'm wondering how, in your communication with clinicians, how do you navigate something like patient research authorization? So like patients, do they have to consent in order to be part of this genomic repository, or how does that work?
So everything you see here, if you ignore step 5 and the federated lines, everything you see here would be regular patient care.
Mm-hmm.
And so, you know, my patient would have their EHR data. I would send them for sequencing. So this would be kind of like, you know, I was a doctor at Kaiser for 20 years. And when patients joined Kaiser, they signed a default. You know, your doctor can, you know, look at your data. So there wouldn't be any special authorization necessary to set up the clinical applications. But when we start talking about translational research, their special consents would need to be in place to authorize the use of this data for secondary purposes. I don't know, did that answer your question?
Yeah, I think so. So number 5 needs consent. Everything else would be general patient care. I see we have a hand raised. Manuela, do you want to chime in?
Yeah. Hi, Manuela Benawi. I'm from the Charité Berlin. Thanks for this overview. I have a very technical question. If you're talking about moving genomic data into FHIR, what's the advantage of that? I mean, VCF files are structured, BAM files are structured. What are you gaining by using FIRE?
Yeah, I mean, the biggest problem that we're seeing now is, and the main areas where we've been looking at it is there's some subdomains, and really it's it's the oncologists that are dealing with patients with advanced solid tumors. It's pediatric geneticists that are dealing with patients with rare disease. They get the curated report and it's like, oh drat, doesn't have everything I need. I really could look at a broader piece of information. So we're seeing more and more clinicians ask for the VCF file. And in the era of polygenic risk scores, we're now seeing labs, at least some labs, trend towards producing GVCF files from VCF files. And these are big, right? These can be 10 plus gigabytes. And so clinicians working on their workstations don't necessarily know how to manipulate a VCF file. And so the idea here is the VCF file is in here. We're not converting the VCF file to FIRE. The BAM file is in here. This is the genomic repository. But if in fact, using a Smart on FIRE application, I decide that I need to look at the BRAF gene, I can make a call to the repository, and rather than having to send over the entire VCF file, I can take just that slice that's relevant to me, and I can return it over to the app. And what we're finding is that a lot of clinical informaticists and a lot of clinical informaticist app developers who are very comfortable with FIRE and have growing familiarity with FIRE, they still really struggle, with the VCF file. And VCF files have a lot of nuances. And even for people that have been using VCF files for a long time, when you get a VCF file through a new pipeline or through a new lab, you kind of have to think about it a little bit. And so what we've been trying to do here is, behind the scenes, we have a VCF to FIRE mapper. So the clinical informaticist can simply say, I need to look at EGFR, and I need to look at the molecular impact of the pathogenicity of my patient's variants. If we invoke these APIs, and if we say to the server, just give me the relevant slice of VCF, and if we translate it into FIRE, and that's really where our bioinformaticists come to bear to really make sure that we have a very high fidelity mapping between VCF and FIRE. Now, when I return FIRE back to the application developer, I wouldn't say it's easy, but it becomes very fun for them. It becomes probably 2 orders of magnitude quicker to build apps, and it allows app developers to begin to think more out of the box and focus on app functionality rather than how the heck am I going to help my clinician understand how to parse and leverage a VCF file.
Okay, thanks for clarifying. Yeah, because I thought you were really going to transform VCF files completely into FIRE. I mean, that would be a JSON standard, and I was wondering how that actually would work, and it seems kind of tedious and slow.
Yeah, I agree, and it would be hugely voluminous too if we had to convert so this repository, for the most part, will not be FIRE data. This will be This is raw data, and it's on the fly. When I request a slice, only that slice is extracted using all of the high performance bioinformatics tools, then converted into FIRE and given back to the app developer, because the app developer, when they receive something in FIRE, it's like, oh, okay, it's just another FIRE feed for me, kind of a thing.
Okay, yeah, thanks for clarifying.
Okay, yep, thank you. So I'll move on. So this is, it's an early mock-up, and Catherine Bloom is on the call. Catherine's been actually coding this for real. And so again, this is an early mock-up. This isn't actually the latest prototype. But I just wanted to show you some of the features on here. Oops. Get these floating controls out of the way. So one of the things is the common ranges here. What we did here was, because the molecular tumor board model is based on the notion of a referral, we know who the patient is. we know what their diagnosis is, we know what their tumor type is. And so we're looking for ways to make as easy as possible for the oncologist to come to a treatment decision. And community oncologists may know what genes they need to look at for, for lung cancer, but for some other type of cancer, maybe that they don't have as much experience with, they may not necessarily know what the actionable genes are for that particular tumor. So there's a little back-end table, and this is configurable where we can, where the clinician can click this box, and then what's going to be displayed here are just those genes that potentially have actionable variants. The clinician can pick other default gene sets, but the clinician can also add other genes in here, or they can even put in intergenic regions in here if they're interested. They really can put in any range they want, because again, the model is that this tool now has access to the patient's whole genome. And so here, the other thing that we've found is that negative results sometimes need proper context. And so here, for instance, if I'm contemplating enrolling my patient in a study, and one of the inclusion criteria for that study is the presence of ALK fusions, and I can see here that my patient doesn't have an ALK fusion, I might say, well, is that because we looked and didn't find one, or is it because we didn't look? And so we're still playing around with visual cues. Here we can see that the patient was tested for the ALK gene, but that testing only included simple variants and copy number variants. So included in the scope of this patient's test, there was no assessment for ALK fusions. And so one of the things we want to play around with is, how do we make it clear? Because, and we won't get into that level of detail, but what that means is we can now also compute that if we're assessing this patient for their eligibility for a clinical trial, where the clinical trial requires ALK fusions, we can pop up on the genetic testing tab, hey, consider test A, B, and C, because it will pick up additional variant types, or it will assess additional genes that may allow you to determine eligibility in a different set of clinical trials, which we currently can't tell because we just don't have the data for. So our ability to now compute the metadata for the test allows us to actually use it to suggest potential genetic testing, where that testing that was done may not have covered the scope that was necessary. The other thing that we're just beginning to experiment with is the ideal workflow for allowing a clinician to submit a variant back to ClinVar. And this is a project that I anticipate we're going to be doing with Alex. I guess this will be possibly another Vicc collaborative project, where here we've shown, okay, here's a variant in EGFR. We didn't find anything in ClinVar. We didn't find anything in Civic. And so we can give the provider the option to submit to ClinVar. Part of the ClinVar submission pipeline requires some computation that predicts the oncogenicity of the variant. And so the other thing that we'll be adding in is a computation of oncogenicity. And just to digress a minute, the computation of oncogenicity, and Beth, I hope I don't sound too much like a dope, because I know that you're got a gazillion times more expertise in this area, but I just feel like there's a lot of opportunities there for adding into an app a predicted oncogenicity, particularly when you see a novel variant and you're trying to decide, is there enough here that I should treat based on this? And so I think our ability to calculate oncogenicity will help guide the clinician as to whether they think it's worth submitting this to ClinVar, but possibly more than that will help let the clinician make a treatment decision, especially in the context of a molecular tumor board where you had a number of experts in the room that are kind of collaborating on this decision, given if you have a novel variant and you have a predicted oncogenicity, will that allow you to make further treatment decisions, or will that allow you to say, well, we predict that this particular variant, even though it's never been seen before, is likely to be oncogenic. So maybe that satisfies the criteria for inclusion in a clinical trial, and maybe that satisfies the criteria for treating with some type of medication. The other thing here that we're still kind of experimenting with is, how long can it take to load this screen before clinicians get pissed off? We've been experimenting a lot with visual cues, because when you have a tool that has access to the patient's whole genome, you can really soup up that tool and provide pretty rapid speed, but that requires a pretty powerful machine. And so we anticipate that, if you're trying to pull in all variants with annotations for a broad range of genes, this probably going to take a certain amount of time to populate the screen. And so we want to provide some visual cues on that. Sean, I didn't read your question, but do you want me to pause and go over your question?
Sounds good. Go ahead, Sean.
Yeah, so you mentioned, Bob, earlier that you were going to give clinicians access to the VCF through the app. And the labs, through whole genome or a virtual panel or something like that, generate VCFs all the time, presumably within a relevant target space, and generate, as you said, a curated genetics report. If something was on the VCF but not reported, there may be an underlying reason why it wasn't reported. Either it's likely benign, a tier 4 variant, for example, or it's not a validated target within the reportable target space. It's got low coverage, it's got this or that. Just because it's in the VCF is or is not in the VCF doesn't mean it was a validated target. And then clinicians would use an AI tool or something like that to determine oncogenicity of this variant. And then you just said perhaps treat based on the presence or absence of this variant, which was not in the curated genetics report. I would posit that the best thing, if a clinician had a specific question about an ALK fusion, presence or absence, something like that, the best route would be to talk to the lab that generated the data to see whether or not the absence or the presence of this variant in the VCF, is it a validated target? Is it not a validated target? Did you actually sequence, or did you actually look for fusions, yes or no? Giving clinicians access to the VCF would be like opening a Pandora's box. I know that clinicians, so up in Canada, some clinicians are absolutely experts in genetics and some not so much. And so that raw VCF, I think it'd be a problem.
Right. And to me, I guess I would say that's maybe the $1 million question in what we're doing. And I would also say, currently, because we're working with synthetic data, it's been really hard to find what we want to do in our experimentations is have the VCF and have the curated report in parallel. And there will be filters in here so that you could just click a button and only show what was in the curated report. But even when we talk to like Tempus, for instance, and I don't know if anyone from Tempus is here, but they're part of the Genomics community. When we ask Tempus, how do you view the VCF file? And they make the VCF file available now because they have their customers who are asking for the VCF file. They say, okay, the VCF is research grade. And so the question is, are there safe circumstances where you can expose research grade data to clinicians? And, when we start talking about clinical trial matching, it's pretty quick that people will say, yeah, that seems to be at least one safe thing, because you're not necessarily going to, I'll give an extreme case. I'm not necessarily going to find in the VCF file a BRCA variant and refer my patient for a mastectomy. There's going to be many other steps along the way, but I would still probably prefer to know that variant is there. So I guess what I'd say is I 100% embrace the complexity of your question, and I don't completely know the answer to that, other than to say I do believe that we're going to find places where exposing that data to clinicians through something like this, initially under the auspices of an IRB, we'll find places where we can expose the patient's whole genome for decision support. Yeah, Beth, I see you have your hand up.
Yep, thanks. The other issue that I'm kind of seeing here is that a lot of clinical labs are the ones that generally submit to ClinVar. So would we be, potentially creating an issue where you might end up with duplicate entries for the same patient in ClinVar based on the same work, So I don't know how often clinicians generally submit to ClinVar, but I do know that clinical labs, at least when I'm working up a variant, I'm looking for other clinical labs in ClinVar.
Right. And to me, that's because it's also possible that two different oncologists looking at the same patient might choose to submit the same variant. And so we definitely, and I don't know at this point how we'll do it, but we definitely would want to avoid redundant submissions.
Right.
Yeah.
Yeah. So it'd be something to kind of keep an eye out for. And then, yeah, I think that to Sean's point about giving clinicians the kind of the freedom to see the data unsupervised, that gives me a little bit of pause too, but it really depends on the expertise of each individual clinician. I don't know how often clinicians are, overestimating their skills, or if they're pretty self-aware of kind of what each test that they order sees. But I do know that the clinicians that I speak to are generally very spread thin. I'm kind of thinking about this a little bit. In the pathogenicity column that you're showing, is that the pathogenicity as determined on the clinical report, or is that determined by ClinVar or some other mechanism?
Currently, because this is all synthetic data, we don't actually have any cases where we have a VCF file and a curated report to play with. And so everything that you're seeing currently in pathogenicity is this variant was dynamically found to be associated with this particular variant in ClinVar, and we simply ClinVar annotations.
Okay, and so sometimes you'll get conflicting things in ClinVar. And then also, if you're working with reports from different laboratories, you may have one laboratory that categorizes as tier 1, tier 2, tier 3, another one that will classify as oncogenic, likely oncogenic, and then a third one that might classify as pathogenic and benign. And so I think that your model might need to be able to ingest kind of that level of data as well. So
the other thing, we've gotten, and this, I think this mock-up was built about a year ago, and anyhow, it's a little bit dated, and I love the feedback. Some of the other feedback we've gotten on here is be careful, because you don't want to annotate a somatic variant with a germline annotation.
Yeah.
And so we kind of, I guess I was starting to feel a little naive, right? And one of the reasons that we were like really pleased to be able to come here is exactly for this type of feedback. And one of the types of collaborations that we were looking at is, are you guys interested in, if we get the grant, we do this for 3 years, can we come back and meet with you quarterly to say, okay, thank you for all the feedback, we've made these changes, does this align more with what you think people would use? So anyhow, that's kind of where we're going with this. This was a somewhat of a naive markup from a year ago. Yeah.
Well, it's always a work in progress. That's why we're here.
Right.
So
Yeah.
I
Yeah.
appreciate that, and I think it is a noble cause wanting to just make data more available to clinicians and to everybody along the line. So I applaud that. So sorry, I'll let you continue.
Okay.
Thanks, Bob.
All right. Well, thanks. Let me, I think there's only a couple more slides. So there was the sequencing tab, the annotation pipeline. We did some experiments under Sync for Genes. We did it in collaboration with Larry Babb from ClinVar and Alex Wagner from Civic. And what we did was we took knowledge snapshots from ClinVar and from Civic, and we encoded the knowledge using the draft GA4GH variant annotation specification. Anyhow, under this project, we simply show that you could take patient variants and you could dynamically intersect them with the GA4GH encoded knowledge and return that information as dynamically annotated patient variants. But the other thing is, in talking to Alex, at least at Vicc, talking to Alex at Civic, is his sense that not many people are taking advantage of Civic, and if they are, they're doing it in a very manual way. And probably Beth and others on the call have a much more firsthand knowledge of the validity of that statement, but that was his sense. And so what we're trying to do here is, in part, decrease the manual curation time. If you're a variant scientist, or if you're an oncologist or whatever, if you know that this is my curation process and you're going to be going to these 6 knowledge bases, well, what if I can simply pull that in and display it to you on an app, and at least cut down the time it's going to require for you to do manual curation? Is that going to be of value to you? And partly I say that because when you look at what we're trying to do here, I still think that this is not enough to say, here's the treatment you want to use. Really what we're trying to do, first is pull in all of this stuff that you would be wanting to look up anyhow, to at least cut down on manual curation time. And also just remind you, hey, there's this drug that I had forgotten about, or I had never learned about. And so I have this variant. And so we can remind you that there's treatments available for particular variants. And we can offload some of the manual curation time by having these pipelines. But we also know that there's a lot of information in Civic where it's not necessarily straightforward to automatically intersect that knowledge with patient variants. And that's because some of the Civic knowledge are really categories of knowledge. And so one of the projects that we're working on now is automated annotation of variants with this categorical knowledge from Civic. Yeah, Manuela?
Yeah, thanks. Maybe a bit devil's advocate question. How much does that differ from any representation you would see in the CBio portal instance, where you can actually see variants and you have a connection to Civic and OncoKB already, and you have also an annotation for functional assessment?
Yeah, and we looked specifically at CBio portal, and we looked at the Civic annotations in CBio portal. And I guess I wouldn't say I've looked at it extensively, and I certainly don't want to offend anyone, because we love CBio portal. I just think it's an amazing tool. But it looks as though, without digging into it, that the way that they associate a variant with something in Civic is almost, it has to be based on the same string. And so there's just dozens and dozens and dozens of cases where there is something in Civic that would be applicable to a variant that was identified that just doesn't show up in CBio portal. CBio portal tends to do a better job linking things to OncoKB than it does to Civic. And I don't know if other people have had experience with that, but what we're finding is that's still pretty challenging to automatically annotate with Civic. Maybe I should better just jam through. Oh, anyhow, so I'm going to just jam through to the end. Yeah, because I guess we're short on time. Sorry, I rambled a little bit. So anyhow, I would say that I do feel a little bit naive about the app for want of, real world oncologists and clinicians to kind of weigh in. And we're trying to figure out as we go forward, what we would really benefit from is real world experts who can throw stones at what we're doing and really make sure that the applications that we're developing and the learning model that we're developing resonates with those on the ground who are having to come up with treatment decisions for patients. And maybe Beth, I'll just stop there.
Sure. I have a couple thoughts. One is you're clearly working with the GA4GH group, so VERSE and which is the variant representation group, and then also the categorical variation group that you had mentioned. Those are, you had mentioned Larry, Bab, and Alex are very instrumental in those, as well as Civic. The other thought, if you're not already connected to them, would be there is like a meta knowledge base harmonization team through Vicc. Alex is also involved in that. And so he'd be able to, there's kind of a need to maybe harmonize data through some of the annotations that are being made through VERSE, through a system of knowledge bases. And the hope is that the adoption of those standards that are being made through GA4GH will be adopted into kind of knowledge bases first, and kind of branch out to, commercial entities, and eventually kind of be the path of least resistance for adoption into like clinical laboratories and things like that. So I can connect you with Alex for sure. I think that this group is a good one to come to if you want some feedback on this, or even if you would want to get a couple use cases, run it through the system, present it to this group periodically, and then we could give you whatever feedback you need. I think that a lot of people on this call are not necessarily clinicians and oncologists, but a lot of us are more on the variant scientist and informatics realm. We do have some oncologists that join as well, but we kind of get a broad spectrum on this call. We might be able to kind of give you the feedback from those different perspectives, if that sounds good to you.
Those all sound good, yes.
Okay, so we can connect you with those groups and kind of keep in touch with the grant, and we can bring you back for more discussions. I think that the feedback you got today was, I mean, we're giving a critical eye to what you've done, but I think it's a really great effort to create an avenue for data to flow. And of course, there's going to have to be some kind of, guardrails or mechanism to get appropriate information in different parts of the application. But I think those are all things that are good to bring up, and then you guys can keep working through that. So that sounds great. Well, do you have any other questions from me or from us? Any other feedback?
Yeah, Yuri, do you have any questions?
I think the dialogue and questions and feedback was extremely valuable to us. I think we'd love to, on a regular basis, make quarterly meet up and progress with this, because that's the only way we can make this better and useful for a broad range of people. And so we'll follow up, happy to come back. we're submitting this in the next few weeks. So I don't know if your organization could maybe send a letter of support to sort of just say we've met and we see opportunities
Sure.
to continue dialogue. So it'll help us sort of demonstrate that it's more than just us who are interested in this pipe dream, but it's been really, really valuable to hear. And our emails are available as well. So we welcome anyone who would like to have a one-on-one, and we can provide more information, give you access to the system. But thank you everyone for your feedback. Very useful.
You bet. Yeah, I can, if you're okay with that, I can send your email out with the link to the YouTube recording of this. I can send your emails out and people can reach out at their will after this presentation as well.
That would be great. Yeah, thank you. I still, Sean's question is still resonating, because to me, that's the elephant in the room is, you know, are there safe harbors where we can expose the patient's whole, you know, how many people talk about birth to death use of a patient's whole genome, and yet we can't crack that nut if we can't find safe ways to let that full data set be used. So anyhow, I just really appreciate the question. And
Yeah.
I know that it's still very complicated to answer.
That's why we have jobs, right?
Yeah. Yeah.
Great.
Well, thank you guys so much for the thought-provoking questions. It's definitely something Yuri and I will have to regroup on.
Great. Well, thank you so much for coming and showing us your work. Looking forward to communicating with you again in the future.
Great. Thanks, Beth.
Thank
Bye,
you.
everybody.
Bye.